AP Statistics, Chapter 2 review. So in this chapter, we mostly went over normal distributions and word problems. Um, word problems related to normal distributions. So that's what this video will be about. But first, I'm gonna go over a couple of key concepts and then go over word problems, which in my opinion, at least, those make those concepts even easier to understand as do the problems. So first, go over one concept that the area under the density curve is always equivalent to 1. So meaning if I have this density curve over here, right, and oops, and this area, this might be, I don't know, might have an area of like 0.25, something like that, since the whole thing has an area of 1. And then this area might be 0.5, since it's looking like this chunk is about half of the total thing. And so, this, whatever shape the density curve has, if it's uniform or just weird, or like if it is roughly normal, which I'll go into later, then no matter what, it always has an area of 1. And by 1, it means 100%. Since 100% of the data is in this location. So by this, I might say, okay, well, 25% of the data is at the green line, where this green line is seems to me like about 25% of the data is over here. Another key concept, this is now we're getting into specifically normal distributions, right, is the empirical rule. But first, what is a normal distribution? So in a normal distribution, the mean, right, which is a Greek symbol mu, that is equivalent to the median, right? And so it's normal distribution is also symmetric, has a bell shape, kind of like this, um, like how this one is. And so they're represented, right, as a notation. It's n for normal distribution, the mean, whatever the mean is, comma, standard deviation. And this symbol represents standard deviation. So and so in this video, by the way, I will not be going over mean and standard deviation since those we went over in chapter 1. So if you need a quick recap, then quickly take a quick Google search and then come back to this video. So in a normal graph, a normal distribution, this, right, the median and the mean, and then the mean plus the standard deviation and the mean minus the standard deviation, right? So that's orange to orange. And so in this region, this whole orange region is 68% of the total values in the data, right? However many data values are, this is 68% of it, right? And from purple to purple is 95. So obviously this isn't accurate. Probably could have been something more close like to this, but you get the gist of it. Purple to purple is 95% of the values, and then red to red is 99.7% of the total values. And so as you can see, the red to red, for example, is mean minus 3 times the standard deviation, and this red is mean plus 3 times the standard deviation. So that's, it starts from mean, I guess you could say plus 0 times the standard deviation, and you're going minus 1 plus 1, and minus 2 plus 2. Another key thing, well, this was in chapter 1, but we didn't really do much of this, but this comes a little more handy now, is a z-score. So z-score is the value minus mean, and that difference is you divide that by the standard deviation. And so this is used when, since a normal distribution, right, you're still going to have a whole lot of different means and a different standard deviations. But if you want to kind of standardize it, right, make it one thing so it's easier to tell, we use z-score for that. And so the z-score, I'll get to later what it tells us, but in a standard graph, right, in a standard normal graph, that's just what it's called, right, you have a mean of 0 and a standard deviation of 1. And so the z-score tells us how much. For example, -1 might be here, so then -2 is here, right? And so since -2 is that's minus 2 times the standard deviation, so from -2 to +2, we know that that is about 95% of the whole values. So the z-score tells us it standardizes everything, so it's on the same playing field. It has the same mean, the standard deviation. So it's easier to know how how much, say, a value is higher than the mean compared to another one. So now that we've gone over these main concepts, go over word problems. Normal distribution type practice FRQ. So there are two major tests of readiness for college, ACT, SAT. So obviously this one's from before when it had a score of 2400, the SAT. But basically it says ACT has been roughly normal, which is that's how we're gonna do it. It's roughly normal, mean of 20.9, standard deviation of 4.8, and SAT score was also roughly normal with a mean of 1499 and a standard deviation of 319. So it says Jose scored 1770 on the SAT. Assuming that both the tests measure the same thing, what score on the ACT is equivalent to Jose's SAT score? Explain. So the way we do this is like this. So first we'll go, so for the SAT, we have we're gonna calculate Jose's Z-score, and I'll get to that why later. So the way you calculate Z-score, I said again, is the value. So he scored 1770 minus the mean of 1499 over the standard deviation, which is 319. After putting that in your calculator, we get 0.85. So that is the Z-score. Whoops. That is a Z-score for the SAT with a value of this. So now we have the this, which is important. Like I said, the Z-score helps us, have like an equal playing ground. So with all the different means of standard deviations, we can normalize it back on to 0. And so now it says, assuming that both the tests mean the same thing, what SAT score would be equivalent to the SAT score of 1770. So with the Z-score of 0.85, right, we have to find what value would give us a Z-score of 0.85 using the ACT mean and standard deviation. So let's just use X, right, for our value, minus the mean for the ACT, which is 20.9, minus the standard deviation for the SAT, which is 4.8. So then now it's just a little bit of algebra. Basically, we would do 4.8 times 0.85, and then you would divide that by 20.9, or sorry, no. You would then add 20.9 to that, and so then you would get that the value is 24.98. So this tells us that a score of 24.98 on the ACT is equivalent to a score of 1770 on the SAT. And that's just because the Z-score, right? We want to find what value, since we found the Z-score of the SAT, right? Since we put it in a normal playing field, then we put that in the ACT, so then we made it to for what basically what we're saying is, okay, you got 0.85 is your value for a normal distribution with a mean of 0 and a standard deviation of 1. So what would that be with a mean of 20.9 and a standard deviation of 4.8? And that value is 24.98. And it's basically saying Tonya scored 1320 on SAT. So what percentile would she be in? And so let's see how to do that one. So here's what we would do. I made like a little graph to make it easier to visualize. We have our mean, we have our, this is what she scored, 1320, and you find out what percentile is this in, basically meaning what percent of values score less than or equal to 1320. So first what you do is, in your calculator, you type in, or not type in, but do normal CDF, which I'll explain to you in a sec. And then we do like a very small number, right? Basically like the minimum what her thing was. Basically, since we want to do 1320 and less than that, the mean and the median, we get this number 0.2875. So that says she's in the 29th percentile. So in your calculator, what you're going to want to do is, once you turn it on, you're going to go to, make sure you're on the home screen, right? So you might have to press second and then mode, basically quit. You're going to go to second and then vars, or like distribution, right? And so you're going to go to option 2, which is normal CDF. And so on normal CDF, you're going to set the lower to, like a very small value. Upper to what her was, 1320, right? You're going to set the mean then to 1499. And then you're going to set the standard deviation to 319. And from that, we get 0.2875. Or 0.2874. And so then with that, you're going to round that up. So let's see, that's about in the 29th percentile. And it's basically asking, it's saying Tonya scored 1320 on SAT. So what percentile would she be in? And so let's see how to do that one. So here I've made another graph to kind of display the problem. So the median of ages is 54.6. We know Obama had an age of 47, which is the 11th percentile, meaning the area is 0.11. So what we're going to want to do is, again, we can use this in our calculator. At least part of it is we're going to do inv norm. Right, and we're going to want to standardize it since we don't know the standard deviation of this particular graph, but we do know that, hey, if you have like a standard graph, right, so in this section, which has an area of 0.11, right, but the standard graph has a mean of 0 and a standard deviation of 1, and since this 0.111 is on the left side in the calculator, there's going to be an option for left. And so then I believe that gives us the value, right? It'll be the same process as how we got to normal CDF. It'll be second and then vars, so basically the distribution one, right? And so the inv norm, that one you're going to do 0.11 for the area. Standard mean of 0, standard deviation of 1, the tails on the left side. And that gives us our z-score, right, of 47, which is negative 1.227, about. Basically, that just says that, hey, this is going to be on, since it's negative 1.227, right? So the standard deviation is 1 of a normal graph with the mean of 0. That means that this is about 1.25 standard deviations less than the mean, Obama's age. Once you do the math, you'll see that, yeah, and once you find the standard deviation, you'll see that, yeah, that seems accurate. So now that we have that, right, we know that, I'm going to erase this actually so I have a little bit more space. So we know that negative 1.227 is equivalent to 47, right? Because the Obama's age, that's the value, minus the mean, 54.6, divided by the standard deviation, which we want to find. So then, take algebra right now, you're going to multiply both sides by the standard deviation. And then we find out that standard deviation times negative 1.227 equals 47 minus 54.6, which is negative 7.6. Then you divide both by, right, because there's times you're going to divide both by this. We find the standard deviation alone, which is negative. The standard deviation is about 6.194. So now we can go back to normal CDF, right? Since we have a standard deviation now, we can go back to normal CDF, right? And so it'll be like a super low, 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 low value. Because basically now what we have is, this is what is 54.6 over here, 57's over here. We want to find this. So basically every single value less than 57. Kind of hard to differentiate, but 54.6 here, 57 here. So every single value less than or equal to 57. So we do like a really small number here, right? Then it's gonna be the highest, which is 57. Then it'll be the mean, 54.6. Then it'll be the standard deviation, which we just found is which is 6.19. So now that we do that, just put that into our calculator. I'm doing it right now. Oops. Oh, okay. So that tells us that the z-score for that is 0.651 about, which is 65.1%. And so out of the values we see that 65.1% is very close to 65.17%, which is option B over here. And that's it for now. Thank you.